Thanks. Yeah. Thank you. And Ned, thank you for adjusting expectations. This is not a great idea, but we talked ourselves into it. I used to like to present at my old job, and it's been a while, and I'm out of practice, so I am doing this. And I specifically did not eat any pizza before this so that I'm not panic burping the entire time, which would be funny, but maybe not the best use of our time. So I had an idea for a talk, and this idea kind of popped up during PyCon 2025. I don't know if anybody here got to go to PyCon last year. It was in Pittsburgh. Pittsburgh is no Cleveland, but it was a pretty cool place to visit, and I had a good time. And I got to spend some time in what we call the hallway track, which is a very fancy way of saying talking to people in the hallway. Yeah, sorry, a little ahead of my slides. My timing is excellent. We were talking about all kinds of different subjects, like what are you working on, what libraries are you using, what tools have you tried out. And of course, if you know me, I use PyTest a lot. I was sort of put in charge of teaching people how to write tests at a previous job, so I tried to learn it really well. I am a terrible academic learner, which you're going to see during this presentation. But I don't like being wrong, and I hate giving people bad advice. And that was very motivating to me. So I learned a lot about PyTest. I use it to teach people how to do software testing. So I was bringing up PyTest a lot. And I was getting a lot of feedbacks along the lines of, well, like grumpy engineer noises, if you're familiar with those. And kind of like backhanded praise, like it's trendy, so we kind of have to use it now, or I don't know, it's okay, I guess you can use it. Just don't use any of the weird features, and it's okay. And as a connoisseur of weird features, I was intrigued by this. And I mean, I know PyTest. It is kind of weird, to be fair. But that kind of got me into, and this led to the idea for this talk, which is, well, how can I maybe improve that reputation that PyTest has picked up? If you're not familiar with PyTest, it is a software testing framework for Python. And I would say that it is more Pythonic than other frameworks. And that is to say, if the word Pythonic sounds weird, it is. But basically, it follows the style, principles, and idioms of Python. It is, in the sense of, it is expressive. You can do more and less code. It is idiomatic. A lot of common patterns are there already, batteries included. You're not reinventing the wheel all the time. It is simple, clean, flat, sparse, all those things that the Zen of Python say are good, or better than the opposites most of the time. There's also that one about explicit is better than implicit. And this is, I think, where a lot of people get really mad at PyTest and maybe refuse to learn it or refuse to use it to a degree. We'll talk about that. And these are all, of course, from the Python improvement document number 20, the Zen of Python. If you're curious, I will be releasing these slides, so you can actually click on these links if you're interested. Ned will help me figure out how to do that. So in this presentation, I will be trying to provide a little bit of a background on automated software testing, what makes it easier and more reliable. This is something that I don't know. I'm not going to say that I'm good at it, but I've taught it to people. So to some degree, I am OK at it. I will try to stick to the how and why of PyTest. I feel like every time I try to present on PyTest, it turns into me trying to teach PyTest, which is not good for this amount of time that we have. So I'm going to try to not go super deep on technical details. I will answer questions afterwards, of course, and you're welcome to come up to me. I'm happy to talk more afterwards. I try to attend the Python over coffee events as well. Happy to talk about it in a more general sense. With that mindset of why people are kind of, grumpy engineer noises about Python, what are responsible practices? Can we make Python be a more respectable, more attractive thing? So I guess I do want to adjust expectations a little bit. I'm specifically taught, I'm going to say testing a lot in the next 35 minutes or so. And when I say testing, I'm referring to automated Python testing. I think everyone, just to narrow it down a little bit, I think everyone tests their code in the sense that they run their code to see if it works or not. This is about trying to automate that process and specifically testing Python code as opposed to web interfaces or databases or a number of other things. So automatically, not by hand, not by QA department, on the back end. And I mean, it's not to say that you can't use PyTest to test browser applications. I don't know if the creator of Selenium Base is here, but you can totally do that. Hey, check out Selenium Base if you're interested in testing browser stuff. I'm just not covering it today, is all. And I'm curious, who here has done automated testing so far in their experience? Cool. So social distance virtual high fives all around. Who here is kind of more in the, interested or has heard about it or would go to a meetup about it if it had pizza kind of a situation? Okay, that's cool. In fact, as someone who is newer to testing, you might be less confused and horrified by some of this PyTest stuff I'm going to talk about. So that's a plus. But yeah, testing is complicated and difficult. Those of you who raised your hands in the first cohort are familiar with this. It's because software engineering is hard, naming things is hard, and automated testing is kind of like, in addition to doing your regular job, which is not easy, you are now also doing a second job where you have to kind of scientifically, independently verify that your first job was done correctly. That sounds bad when I say it like that, but in my opinion, I like to think of testing as an investment. In reliability, in maintainability, in the time and the free time and sanity of your teammates, and of course yourself in the future. It will also benefit that future you. That is a good person to take care of. So TLDR, I think it's worth it. I'm happy to debate that point further, but for now, let's just say, it's my presentation. I guess we can say I think it's worth it. So I also wanted to just sort of disclaim, you should use the tools that work for you. I'm going to be trying to talk you into PyTest, but PyTest is not mandatory. Opinions are cool to have. I guess what I'm saying is, if you already have PyTest in your project, you should use it or learn about it. To quote Bruce Lee, learn it and then make it your own. This is a better version of that quote. I think the original one was learn it all, forget it all, which is kind of how I learn things in a bad way, but you get the idea. So a little bit of background on automated testing. We talk about unit testing a lot, and I'm pretty sure that comes from XUnit, or I always get this wrong, sorry. SUnit is the original version of this. So in the beginning, this is back around 1989 or so, Kent Beck made an automated testing framework for Smalltalk. And if you're not familiar with Smalltalk, don't worry about it, because later Kent and Eric, about 10 years later, adapted what they called SUnit to Java, and that became JUnit. And that's I would say a lot closer to what we have today in Python. And if you hear the term XUnit, that's just sort of the practice of saying, well, whatever language you're doing, there is a unit testing framework available. It'll be called, whatever your language first letter is, so like C unit or R unit. And of course, just to be different, in Python, we have one of these libraries, what we call a unit test, which I mean it's a more descriptive name, I'll say. But we broke that naming convention. Now, obviously, I'm going to be talking about PyTest, which is different, but I do want to acknowledge the sort of, the influence that the XUnit frameworks have had on everything. The core concepts are timeless. There's a lot of good advice in there. So when I say unit test, or in the word unit, I don't know, I'm veering into a whole other presentation here, but basically, when we say unit test, we are kind of getting at the fact that it is easier to test small pieces of your code that hopefully do one thing, as opposed to big sprawling messes of code that do all kinds of stuff. And we prefer to test functional units. So hopefully, again, relatively small pieces of your code that have one responsibility or one job. And purely functional code is also easier to test. That is to say, a code that is self-contained, code that does not try to hit APIs or talk to databases or do other side effect type stuff. And again, I'm probably, should I have gone there? I don't know. But I think it's useful in putting things in context. But TLDR, simpler code is easier to test and read and maintain. And I realize I'm dropping a lot of extra concepts here, but I guess as a person who has taught this, I want to point out the patterns that make it easier to do automated testing and the patterns that you can also follow to make your code cleaner and more readable and more maintainable. There's a lot of crossover. They are kind of the same picture at a certain point. So they're all kind of interrelated in my point of view. I will say the unit test library, really XUnit in general, is not very Pythonic. It's, I guess, Java-licious. If you know the right word to describe Pythonic, but for Java, please let me know in the Slack or after the talk. But in the unit test framework, everything is a class. Everything has to be a class. This is definitely a Java thing, if you're familiar with Java. Hashtag stop writing classes. I know Jack Diedrich's talk on stop writing classes maybe caused some overreactions and lost some nuance, but this is exactly the thing that he was complaining about specifically. Python is more flexible than that. If everything is a class, class hierarchies come into play. If you know what a class hierarchy is, even if you like classes and like Java, you must admit that maybe this is not the best part of it. I guess the super short explanation is there's a reason people started to favor composition over inheritance and multiple inheritance and decorators and basically anything other than class hierarchies and the headaches they can come with. And it also means that you're basically kind of building a whole testing stack of code inside of your code base, perhaps parallel to your actual code. And I mean, you're hopefully using a framework and extending classes and not writing it all yourself, but you are creating this big old pile of code in your code base. And I mean, that's if you're lucky. Sometimes, this, depending on your code base, you may have multiple giant weird stacks of code that handle your testing for you. And I guess I'll also throw in there, while I'm complaining about it, it can be kind of hard to share code across groups of tests, or what we call test suites in that model. It depends. So PyTest, I think, is pretty cool. Sometimes it feels like I am the only person who's excited to talk about it in a group of engineers. I am prepared to defend that opinion, but I'm a big fan of minimalist code. I also really appreciate in that Jack Diederich talk where he talks about how basically he says something to the effect of, I hate code and I want as little of it in my project as possible. I think that's great advice. Code takes a lot of effort to maintain. Less code leaves you more time to do other stuff. It's, I don't know, it's almost like a physical law to me at this point. So I am really excited about frameworks that can abstract away a lot of that stuff more cleanly. I mean, more cleanly is arguable, but the idea is when you run PyTest, it will essentially scan your whole project. It will locate files that appear to have tests in them and code that appears to be tests, and it will follow a pretty reasonable pattern to do that. So by default, files that begin or end with test underscore or underscore test, like so. It will also look for callables, so that could be functions, that could be methods, and I'm very happy to mention that it is very willing to, if you do have classic unit test style XUnit tests, it will find those and it will run those very happily, and you can use some of these cool features with those. But it will sort of find the functions, and then it will call them, and it will report on the results. And if you are a big fan of the explicit versus implicit aspects of Python and being Pythonic, you might already be uncomfortable about this, but I guess what got me, because it is very different and a bit jarring, is if you're writing an XUnit style test, at minimum, you need to import the unit test classes and tools that you're using. You have to instantiate a class to be a container for your tests. Then of course you make methods for each case. And then of course you also have to have some kind of code or config or another utility entirely to actually run your tests. Whereas over in the PyTest world, you write a function. There must be more. Nope, that's it. So getting all of that logic out of your code and into a standardized framework where you don't have to worry about it too much is really helpful. And it could be kind of alarming if you're used to customizing things yourself, but I am pleased to tell you that PyTest is incredibly customizable. You can basically change anything you want about how PyTest works, how it identifies these tests, how it displays the results. There are various escape hatches and options if you want to sort of like quarantine PyTest to one part of your code base, if you want to have it avoid certain kinds of files. The sky is the limit. And again, I got a little ahead of the slides, but it is also very happy to work with older style tests and assertion libraries too, for the most part. I will say, again, this is about being responsible with PyTest. Just because you can change anything about how PyTest works, maybe apply the Jurassic Park rule. Like, should you change anything about how PyTest works? There are no dinosaurs in PyTest. But so I would recommend, if you're new to PyTest, at least try to use the defaults before you start changing everything. I don't know. Again, there's a learning curve, but I now find the defaults to actually be pretty reasonable. They go along with how PyTest works. Also, if anybody else works on this code base, they'll be less confused if you haven't changed everything arbitrarily. And I would say, obviously, exceptions for edge cases are usually safer. Like narrower changes are usually more ideal, as opposed to changing all the rules at once. And I don't know if I put this in the slide, but PyTest is so customizable that aspect of it was actually spun off into a library called Pluggy, I believe. So if you're curious about how is it so customizable, there's actually a separate library for that. And I would also say, and this is kind of getting at that same argument that was core to stop writing classes, try to resist the immediate urge to transform or mutate PyTest into a different framework that you're more comfortable with. It has its own strengths. I think they're worth trying out, especially if you're already using it in your project or on your team. It has tons of plugins to customize it. You have to write those plugins yourself. I have been pleasantly surprised by someone will say, oh, there was this thing in Java called Hamcrest, and there's a Python version of that, and I wish I could, I refuse to use anything that doesn't have a Hamcrest pattern matching system in it. And of course, there is absolutely a PyTest Hamcrest out there. Insert your favorite testing utility or pattern here. Again, hopefully try to find it as a plugin that doesn't break everything else in your project, but again, PyTest did a pretty good job of designing its internal API and its plugin system. Yeah. So, whoops, sorry, I backed up by accident there. The other thing, in addition to PyTest trying to kind of turn the discovery and test running and test reporting stuff inside out, is a very different take on fixtures and parameterization. And if you are, again, new to testing, when we say fixture, this is borrowed from a mechanical engineering term. If you are, say, instead of making software, you're making an automotive braking system for a car. If you had to take the wheel off and jack up the car, maybe not in that order, to take off the brake assembly and modify it every time you ran the test, that would get really old and dangerous. So what you probably want is something that's just enough like a car axle that you can fit on your desk so that you can, have the brake pad right there. And so you might say you would put it on a fixture so that you could work on it. So obviously we're not talking about automotive parts here, but a fixture is a thing that helps you run a test, and then parameterization is the whole thing that I'll get into. And this is perhaps the best and worst part of PyTest, depending on your opinion. And again, to contrast, the classic XUnit style, what you would see in the built-in Python unit test library, you have, as part of your class, there's a place to have setup code that runs before your tests to get resources ready, to maybe do some mocking, which we'll talk about. And of course, you have your tests themselves, and then you maybe have some teardown code. If you need to clean up anything after your test or between your tests, like putting on a new brake caliper or something, that could all happen there. And I'm not saying this doesn't work. This does work. I was a Java engineer for like 10 years. It's definitely workable, but it can be a lot of code and complexity. Again, getting into classes and class hierarchies and class inheritance and sharing stuff, trying to not repeat yourself over a large code base that has a lot of these classes in it can be complicated. There are also some great talks about good complexity and bad complexity, or being complex versus being complicated. I think it's veering into the bad kind, in my opinion. So in the PyTest world, again, try to remember that essentially PyTest is this sort of external thing that we invite into our code base and tell it to do all the work. So in the simplest form, a PyTest test is just a callable. That is to say, it is a function or a method on a class that has an appropriate name. And if PyTest finds one of those, it will nicely tell you that it found it. It can list all the tests that it has found. It will, and so the simplest test is just a thing that you can call. It doesn't even take any arguments. PyTest will call them and run them and evaluate the results. And this is also the part where in something like unit test, you would have to look up the big list of assertion methods that are built into the testing class, or maybe using an external assertion library, like the Hamcrest library that I keep hearing about, that I somehow missed despite being a Java programmer for a really long time. Might be a European thing, I'm not sure. But in PyTest, you just use the built-in Python assert keyword. That normally doesn't really get you a lot of feedback, but PyTest is also kind of a debugger. So if one of your assertions fails, it will actually unpack that expression and tell you why the assertion failed and what the values were. And there are some cool plugins to make that even more helpful. And where it gets more interesting, where it starts to get the parity with the setup and teardown methods you have in the classic unit tests, if your callable test-like thing does take arguments, these will be named positional arguments in Python terms, that implies a fixture. So again, PyTest is sort of sifting through all your code. It sees what it thinks is a test. If the test has no arguments, it'll just run it. Hopefully it'll run some code and make some assertions. and those assertions can pass or fail. As is often the case, if your code raises an unhandled exception, that'll be considered to be a failure by default, which is pretty reasonable. If your test function has an argument, PyTest will assume that that argument represents a fixture, and it will try to find that fixture and apply it for you. So for example, if I make a test example test that takes a fake database argument, PyTest will assume, okay, somewhere there is another callable thing called fake database. I should really call that first, take whatever it returns, and pass that into the test. So this is, I will say, oops, sorry, I keep hitting the wrong button. Somewhat sketchy, I guess is the word that I used there. Sorry, got a little bit ahead in my slides. So when it sees one of those names like fake database and it wants to go find it, it's assuming that somewhere else in your PyTest code you have another function that is specifically decorated as a fixture. So you imported PyTest, and you can also import fixture directly if you prefer. I'll not get into that argument tonight, but you could just basically say, hey PyTest, this function is a fixture, and it will now match that name to tests that refer to that name. And that is admittedly very different from how Python normally works. Arguably, the names of functions shouldn't matter outside the context of that function in Python. But if you consider this in the perspective of PyTest is a person or perhaps a friendly robot who is coming into your office and running your tests for you, PyTest has to fill out the arguments to the function to call it if they're required. So it's not completely un-Pythonic, it's just a little bit backwards. And of course, fixtures can do whatever you want. They can do your typical setup and teardown stuff, if you're familiar with that from unit test. Fixtures can also return values, and if they do, those will then be passed along to the test. So in the test, you can also access that fixture name, and you can get stuff out of it. It might be another callable, or a generator, or some kind of awesome PyTest or Python thing. You get the idea. And this is also where things start to get really sketchy for some people, and to be honest, kind of including me. Fixtures are name-based, so when you say this function is a fixture, you are essentially registering it based on its name and also where it is in your code base. And so I would say, ideally, in the simplest case, the fixtures live in the same file as the tests that depend on them. That keeps everything really simple. However, if you don't like to repeat yourself, which is that gets me into a ton of trouble in my code, trying to not repeat myself and being clever and massive sarcasm quotes about it, you can make your fixtures be global. I won't get into the details in these slides, but you can basically say, I want this fixture to be available to all of my tests. And it's also worth noting, PyTest includes a bunch of built-in fixtures, which are very helpful and cover a lot of the other stuff that you might expect out of a testing framework. And when you install PyTest plugins, those can also install global fixtures. And that might make you wonder, well, if I can make global fixtures in multiple places in my code base, and they're all based on the name, how do names get resolved? What if there's a name conflict? And the answer is, well, unfortunately, the option that they chose is if you do have multiple fixtures, sorry, it says fixes there, but I meant fixtures with the same name that are in the same scope, the one that is closest to the test will effectively win. And I have to admit, I have a lot of experience explaining PyTest and training people on how to use PyTest, and this one's rough, defending this decision. I'm sure there's a good idea somewhere that I haven't quite grasped yet, but it's a little bit troubling. So I would say, again, to be a responsible PyTest user, to have a good PyTest experience, be disciplined about your global fixtures, if possible. Keep them in one place, ideally. Makes it much harder to accidentally make things with the same name if they're in the same file. Your IDE will start yelling at you in that case. Formally register their names, maybe document them somewhere to avoid conflicts. Also, maybe try to make sure that you're not overwriting any of the built-in PyTest fixtures, although they have kind of short, ugly names. So if you like longer, more descriptive names, you'll have no problem with that. I would also say consider making them into plugins. Plugins are essentially add-on modules for PyTest that you install with pip, like a Python package, but they can include fixtures. And if you put your fixture into a plugin, PyTest will start telling you, here are all the fixtures you have installed, or all the plugins you have installed. It makes it a little bit harder to be surprised about this. I'm not sure if it made it into the final slides. Yeah, believe it or not, these are the simplified slides. But yeah, making them into plugins makes them more self-documenting. A lot of people will tell you that if you're writing Python code, you shouldn't leave print statements all over the place. And that is usually good advice, especially in production code, for a whole bunch of reasons I don't need to go into right now necessarily. But I will say tests are not production code. And one of the things that PyTest does by default is capture all of the output of your tests and hide it until such time as you ask for it or the test fails. So I have to say, leaving print statements around specifically inside of PyTest tests is really nice, because then when your test fails, you suddenly see all that output and you have to go in and manually turn it back on, or I don't know, mess around with command line arguments. So not on the slide, but don't be, well, hot take, don't be afraid of print statements in this particular context. So fixtures have pretty reasonable defaults, and they're pretty easy to change those defaults, possibly too easy again. Like adding another fixture with the same name that is too close to the one you already made is an example of a too easy to change the behavior by accident. But essentially, as far as setup and teardown are concerned, by default, a fixture essentially gets called, I mean literally gets called, each time it is required. If I have two tests that want the same fixture, it will helpfully instantiate that or call that fixture for each test. Each test is essentially now getting its own new, fresh copy of whatever that thing is. I don't have to worry about cross-contamination between my tests. And this is a really good default. This is very classic XUnit style behavior in a good way. However, fixtures can be modified to run once and cache their values across some number of uses. So, wow, no pizza, and I'm already having the panic hiccups. So, for example, you could say, I want this fixture to run once per module, per file full of tests, hold on to that value, share it across all the tests, mostly as an optimization, a way to make it faster. If the fixture is really slow for some reason, calling it like 20 times might make my night a little bit longer. Likewise, you can even expand that to run once per session. Essentially, the entire time you say PyTest run my tests, it will try to hold on to that value for the entire run of all the tests across all of your files and cache it. And that can be helpful. I will say, okay, sorry, partially duplicated slide. I like to refactor my slides at the last minute, which is a fun way to play clever little tricks on myself. Don't do that. It's a bad habit. Speaking of good habits. So the thing about caching values, that is maybe, I don't know. I talked a lot at the beginning of this presentation about how testing code in isolation is good, and avoiding crosstalk across your tests is also good. So retaining state across tests is a thing left over from unit test days. It is an optimization. Sometimes it is really helpful, but it is kind of dangerous. Like we said, it's kind of somewhat in violation of the best practices for easy, safe testing. Also, did you know that cache invalidation is one of the most difficult problems in computer science? Just good throwing that out there for no particular reason. So just use it wisely if you want to use it. And fixtures do have some tricks to help with this. Again, a simple fixture is just a function with no arguments that you have decorated, you've registered as a fixture that does something, hopefully useful, and it could optionally also return something to the test. There is also, I didn't cover it again, simplified, believe it or not, slides. It is possible for fixtures to introspect. There's a fixture that fixtures can use to find out stuff about the test that they're being called in. They can find out what the test is called and what tags it has and other cool stuff. You can make your fixtures smart, interesting ways. And I got a little bit ahead of myself there in the sense that you can make a more complex fixture that does have an argument. And it's the same idea, in fact, the exact same idea as the previous usage. Fixtures can depend on other fixtures. If it helps, so you can think of this as kind of like being a wrapper around a fixture or a decorator around a fixture. If it helps, if these words help, think fixtures and higher order fixtures. If those words don't help, please feel free to ignore them. I'm mixing subjects here a little bit. But the idea is, instead of building and supporting n different fixtures that all kind of do the same thing or similar things, and then you say, oh, I want to change all of these, or wait, where did I put all of these similar fixtures, and why are there now 30 of them? It's nice to maybe create a base fixture that does the thing, and then if you want variants, you can just sort of wrap it. You can have a fixture that just say, I do that, but with this one extra change. I make this thing mutable or not mutable, or give you a fresh copy of it, or whatever. You can avoid, it's an amazing set of tools to avoid repeating yourself, repeating code, and to help keep concerns separated at the same time. These are all things that I think are very good. Less code, less repetition. I make my slides overly verbose because I'm kind of bad at remembering what I'm supposed to say, but I'm amazed at how often I can get ahead of my own slides despite that. So I mentioned parameterization before, and I didn't quite get to it because it is really complicated, but it is definitely worth knowing about. It is also one of those things that gives people the heebie-jeebies when they're not familiar with the concept, but I promise it is less scary and more useful than it might first appear. So you may, if you've done testing, you may be familiar with this scenario where you make a test and it's really cool, and now you want more tests that are like that, so you maybe just copy and paste it and change it a little bit, and pretty soon you have hundreds of tests that are kind of the same test over and over again, and some of them are older, than some of them are newer, and some of them are different in ways that are not particularly helpful. So instead of doing that, what if you could write the test once and essentially get it to rerun, essentially making it, let it fan out into multiple tests with different parameters plugged into it. Specifically, make PyTest do all of that for us, so we don't have to do it. And not just a lot of assertions are running, but like our one actual test is becoming a whole bunch of test cases that can all independently pass or fail and hide their output if nothing interesting is happening. All the cool PyTest, all of the benefits of PyTest with none of the actual writing more code. So, I mean, you could also express this as replacing a whole bunch of similar tests with one test and a bunch of data for that test. And again, you know, with fixtures and everything, these could be different contexts, different starting states, different simulated errors, all kinds of cool stuff. So I will say a lot of people bounced off of this feature because the syntax was really ugly at first. And that ugly syntax is still there with some improvements, but I will say it's better. Anyway, some of these things are maybe like, I don't know, 5 years old, which seems new to me because I don't know, my sense of time is warped post-COVID, but you can now, I think originally they were fixtures. Now you can also basically do them inline. So you can you can parameterize a test right on top of the test. That may make it easier to visualize and understand. You can still implement them as fixtures. If you want a set of parameters that you can reuse across your code base, that's awesome. Likewise, if you want a base fixture that provides parameters and another fixture that modifies them and mutates them, it's amazing how much you can cut down giant lists of parameters by making clever use of that feature. Parameters are also easier to label than they used to be. One of the catches here, and I will fall back on actually showing you some code. If you imagine I have a whole bunch of tests that take a letter and a number and do something with them. So I'll say the letter x and the integer 2, for example, are one set of parameters that I might use in a test. So my test, if I have one test that takes a bunch of these parameters, it might say, okay, see, I have my one test, it is getting parameterized, is getting run multiple times. I will see test x2, test. Those are intended to be different. You get the idea. So if the parameters are very simple and short, it is actually really cool that PyTest just names these generated cases. Like it calls them nodes in the sense that it is building a big graph of all your tests and dependencies. But if they're short, this looks great. However, if your parameter is, say, a 4096 byte base 64 encoded binary object, that's not a good label. That'll take up your entire screen. So there were a lot of weird workarounds for this. There are much better constructs for this now. I recommend using them. You can now, and again, I love that all of the helpers are mounted on PyTest. So as long as you can remember that this framework is called PyTest, you can just import it and access most of the stuff you need right there. So pytest.param is I believe it's a function that you can pass in your parameters, and you can also pass a keyword ID and tell it what you want it to be called. So again, if you don't want that giant binary blob showing up in the name of your test case, this would give you something more like, my test unpack file now has an x-large parameterized set, which is much easier and more informative than x2 and a giant blob of binary data. Naming stuff is hard though. So you can also do this programmatically if you prefer, and I do have to admit I still find myself doing this. This is sort of an old workaround, but if you have a lot of data that you are kind of programmatically remixing together to make parameters, I sometimes find it handy to just say, okay, I'm gonna have a dictionary where the keys are the labels and the values are the actual parameters. And then when I apply this to my test, I can just say the parameters are the values and the IDs are the keys. And it just turns that dictionary into tests that use the same code. And so again, if you are dynamically generating a lot of parameter sets or using iterators, Python has some great iteration tools if you're familiar with combinations and permutations. You don't even necessarily have to write your parameters out. You can have PyTest make them for you dynamically at runtime, which is scary, but super cool when it happens and works. And I should talk a little bit about marking and test organization. So we mentioned like PyTest tries to take over all the entire job, the entire industry of finding your tests and running them and targeting them. And I think I have a duplicated slide here, my apologies. So yes, marks are a very powerful addendum to the test organization. Obviously PyTest can target tests by their location. You can say, hey PyTest, run all the tests in this file. You can even say, run this named test inside of this file. And that's very common. I think all test frameworks generally do that. The cool thing about PyTest though is you can also essentially define these custom marks, or you can make them more like tags, and you can tag your tests. So we do still have the same sort of abstraction of all these tests in the same file are hopefully related in some way. And PyTest is very happy to work with that. You know, so our files are our suites to a degree, our callables are our test cases. If you like that terminology, there's parity there. But if you think about being able to tag your tests, your code can only be in one place at a time, but you can put multiple tags on it. So you can do really cool set operations to do test targeting to inform fixtures. Fixtures can actually see your marks. So you can say things like, I want to run all the tests that have mark A and B, but not mark C. And you don't have to worry about where they are or what they're called. You can just categorize them. So I don't know. It's simple, but it's very powerful. If you do any data categorization works, it's sort of like how buckets are not as cool as tags. Or in this case, you can have both. It might be a duplicate slide. I really messed up this part of the slide deck. My apologies. But yeah, it really does, you know, invert a lot of the expectations of how tests work in a good way, I think. Being able to arbitrarily group things. Frankly, being able to regroup your tests without moving them and disrupting all the other code attached to them is really powerful. It makes refactoring easier. And yeah, and just I kind of spoiler alert on this one, but yeah, you can be in multiple groups. It's super helpful. So I will say, we talked about writing fewer tests with parameters. Another extremely unpopular way to avoid writing as many tests or to write fewer tests is to consider why JUnit and friends emphasized unit testing. And there are a lot of reasons for that, obviously. If you're into functional programming, you probably know a lot of these already. I think there was some early functional programming FP influence on JUnit. Obviously, clean coding practices tell us to do very similar things. However, Java has strong typing and static analysis. So frankly, you don't need to test that all the pieces of your code fit together. Java will do that, will kind of force you to make that work, or it won't run in the first place. So that was part of the emphasis. And if you're familiar with Python, Python is very different from Java. It is not statically typed. It is very dynamic. You can get into all kinds of awesome problems and adventures. You have awesome adventures in Python by playing with the dynamicism of it all. But I will say, Python does have optional type annotations. I might be the only person who's excited about them. Me and Facebook, I guess, or sorry, Meta. But they really have improved a lot over time. If you tried them a couple of years ago, I would say check them out again. Type protocols are amazing. If you wished you could say Python type stuff like, I don't care what what class this thing is, I just want to accept a callable that takes a string as its first argument. I don't care about anything else. You can say that in type protocols, and it can actually enforce that for you. Or you can say, I don't care what order it's in, I just care that it has a certain name. It can do that too. It's really flexible. It is much more Python friendly. And I should also, I don't want to discredit the fact that core Python has done a ton of work to expand and improve itself to support type annotations and type checking. And there are better validation tools. You can get type checking results in real time in your IDE without having to go to a terminal, thanks to Pyrite and friends. And I guess TY from Astral is in alpha now. So there are fast type checkers. And I'm also blown away by how many other cool features and tools and IDE plugins will take advantage of type annotations if you have them. It's a much different world. If you tried it and didn't like it 5 or 8 years ago, it's worth another shot. So hey, I'm actually kind of on time, sort of. In summary, I hope concisely and directly for me the first time in this whole presentation, PyTest is very different from what came before it. It does certainly keep up to it in spirit. It does have a learning curve. It can be alarming if you're not used to it. It may not even be the best tool for some specific job, but in my opinion, it is more Pythonic, shouldn't punch my microphone, more flexible and more powerful than the classic unit testing framework. Again, in my opinion, fight me, I guess, as Ned would say, but not physically. It is worth learning and using properly, especially if you're working in a project that already has it. It really is worth checking it out. It is really cool. It's much like Python itself. I found it very rewarding to learn about it. The more I learned, the more I was more impressed I was by it. And just don't look at my old PyTest code from before I had to teach it to people. And just less politically, as far as what tool you prefer, I mean, you should use whatever tool works for you. Testing is very unique. It's very specific to the kind of project you're working on, the team you're on, the kind of tools you're using, the requirements. Which parts of it are you most afraid of breaking? What does your code actually do? What is important to you? I can't really give you good advice on that, but I would just say tools are meant to be used to your benefit and not just kind of feared and angry engineer noised at. Especially if your project is already using it. I mean, come on, it's there, just use it. So I want to leave a little bit of time for questions or discussion if people are into that, but just as a quick reference, and again, I'll try to release these slides in a form you actually click on all these links at some point in the future, probably on the Meetup page, maybe also on the Boston Python Slack, which is a cool place to ask questions and follow up. Obviously, PyTest is a pretty core part of the presentation. I will say there's a plugin called PyTest Mock. Mocks are a whole other presentation. They're complicated. They're sometimes necessary. Everybody hates them because they're terrible. But PyTest Mock lets you turn them, lets you scope them as if they were fixtures. I can't tell you how many problems it solved for me. I mean, obviously, if you're using mocks, mocks are kind of like regular expressions. They are their own problem. But this makes it so much easier to deal with. PyTest ICDiff, if you're familiar with ICDiff, basically, if you're saying this dictionary is supposed to equal this dictionary and it doesn't, wouldn't it be cool if you got like a side-by-side color-coded diagram of that? That's what this does. It's great. PyTest Sugar, if you were like, why doesn't PyTest have colors and emojis and stuff in it and progress bars? Well, there it is. Many, many, many more. I'd love to hear about your favorites. I will say this URL is really awful, but I did write a whole tutorial. If you want to sort of historically watch me figure out how PyTest works in little example code that you can hack on, it's all up on GitHub. It's very educational. If you're curious more about like exactly how does it do these things, how does it behave, you can sort of watch me painfully figuring that out. And yeah, if you're interested, if the type checking thing got you curious again, obviously MyPy is sort of maybe it's not actually the reference implementation, but it's sort of, in my mind, the most official implementation of Python type checking. It is not super fast, of course, but thankfully Microsoft has released Pyrite. It is high performance. It runs right in VS Code. It can tell you in real time what's going on. That can be a big quality of life improvement. I would also be remiss if I didn't point out Based Pyrite, which is an open source fork that adds more features and makes it a little bit stricter than the Microsoft Based Pyrite. It is super cool. If you were like, what am I missing from my life? It's TypeScript out-of-memory errors. There's a little bit of that as well, but I'm confident they'll keep working on it. It is generally a net positive in my life, though. And of course, if you're familiar with UV and the Astral folks, I believe you can now actually try out TY, which is a type checker written in Rust that is even faster. And I don't know, it's just got to alpha, so maybe don't go nuts, but it's worth checking out. I've also talked to people a lot lately about automation tools. Obviously, PyTest is an automation tool itself, but if you have PyTest and you have MyPy and you have a bunch of other stuff and you want to run all those tools more easily, you could use a makefile, or you could try something like Tox. Tox is a very straightforward way to get started with this. If you want to run all your dev tools in a certain order and run them across multiple versions of Python, make a big chart where you've got dev tools on one axis and versions of Python on the other axis, and just check all those boxes off. It's very easy to get started with. And it'll manage all the virtual environments for all those versions of Python as it tests them. And I've also gotten very interested in Nox. Nox is very similar to Tox, but it's a little bit harder to get into. It has a learning curve. I know, I have a type, I guess. But the cool thing about Nox is instead of just configuring an application, you're actually writing Python code. You're writing little Python functions with decorators. So Nox does all the Tox stuff, but you can customize it in any bizarre way that you want. If you say, well, I like the dimensionality, but I want my dimensions to be something other than tools and versions of Python, you can just change that. You're like, can I have like a 4-dimensional time cube of dependencies? You can. You want to make smart logic, other behaviors, etc. If you can code it, you can automate it. It's pretty cool. In terms of not writing tests, what if you could find edge cases in your test by just grabbing your code and shaking it really hard? That's kind of what Hypothesis does to a degree. It's a bad metaphor, but bear with me. If you've ever heard of Haskell and Quick Check, it is kind of like that, but for Python. And the idea is, rather than writing test cases, you essentially define the contract around your code. How is it supposed to work? What arguments is it supposed to take? Is it supposed to return exceptions in certain cases? And then you let Hypothesis loose on it, and it tries all kinds of weird random crap until it breaks, or until your code does not do what it's supposed to do, and then it tells you. And you can even turn that into a test. Now, I will say, I brought this up because this is another thing that people at PyCon were very mad about. Everyone either loved Hypothesis or hated it with a passion. And I think the difference is Hypothesis is not a tool that you run in your CI/CD pipeline. Like, you don't want to be in a situation where you can't commit your code because Hypothesis is failing. Hypothesis's job is to do weird random crap and find weird problems that may or may not be relevant to you. So I would say, do use it for that. If you have code that has to survive user input and web input and the internet in general, it's amazing. Just don't run it automatically in line with your deploy system. Have it help you generate tests that then you, a human, can maintain. And yeah, that's my slides, and I'm just about out of time anyway. So I also want to thank Matterbeam.com, my employer, for sponsoring this event, for buying the pizza. There's a bunch of Matterbeam swag over here. And yeah.
I have a question.
Yes.
What does Matterbeam do?
That's a great question. So I guess the super short version is Matterbeam wants to help you to solve your data problems. And we try to do things differently than a lot of other products. Are there any data science folks in the house? When you hear the word data lake, do you get stressed out or panicked or intrigued? One of the things Matterbeam is trying to do is realize the original promises and intentions of the concept of data lake. So data lake as a place where you can very easily get your data into it and then find it again, and not just a deep, dark, murky hole in the ground that if something falls in there, it's gone, or a illegal data drainage ditch. We want data to be safe, to be organized, to be smart, to be streamable, to be replayable, to let you take risks and do experiments and not have to worry that you're going to accidentally delete your one copy of your data, to have you not say, why is my bill so high all the time? It is entirely serverless on the back end, which is a huge pain in the you-know-what for me and some of the other developers, but we pass the savings along to you. It is very operationally efficient. It is very reliable. It is very scalable. And we do cool stuff like letting you write data transforms and data operations as little tiny, clean, simple, purely functional units of Python code. And then we do the fun job of trying to make sure that they actually run on all of your data in the right order. So yeah, if you're curious about that or want to hear more, I'm here. Mike is here. He's our founder, also a Python developer. And Alex is also here. Alex, please don't ask Alex about PyTest or Python necessarily, but Alex is happy to talk about data and analytics or 3D printing. We do have 3D printed cable ties over there. And yeah.
Thank you very much, Matt. And we have time for a few minutes of questions. Do we have questions? David nailed it. There's no questions. Andrew.
Hi. Thanks very much for the talk. That was great. The question I have is, how do you decide when to put something into a fixture? I tend to think of arrange, act, and assert. And then do you take everything in a range, or what is your heuristic for moving it into a fixture?
That's a great question. It's funny, while I was trying to sort of fact check myself on some of these things about PyTest, I saw some diagrams of like decision trees, and it was sort of based on how many things, like the volume of stuff, and how many, I guess also the number of times you've repeated it. If you're talking about code or assertions, I guess assertions really want to stay in the test case, and there are some catches to that. You want, again, for the really handy auto-debugging part of PyTest to work, it wants to debug an assertion that is in the test case itself. If it's somewhere else, things get a little bit murkier, although it's OK if you're using an assertion library. But I guess, sorry, to actually answer your question, I would split it off based on complexity. I think someone tried to prove mathematically that like 3 was the right number of things to split it out, or to avoid repetition. Like the don't do it more than twice. Don't do it more than 2 or 3 times, I guess, is a classic rule as well. But unfortunately, it's one of those it depends kind of questions as well. I guess all questions ultimately are. But
does anyone have a non-it depends question?
It was a good question, though.
When is the follow-up talk on the irresponsible uses of PyTest?
Oh gosh, you know, I did promise some irresponsible uses, and I didn't put them. I was trying to cut the slide deck down, but my personal favorites are. I think someone else has done this as a better plugin, but I was testing what is essentially a video game, and so I was doing a lot of cool stuff with a map that had letters on one edge and numbers on the other edge, and pairs of letters and numbers and permutations and combinations of them, and I made a fixture called repeatedly that would just cause the test to get run like thousands of times. And so you could basically say, this is a repeatedly test, and I want to crank up the repeatedly factor until a test fails and then turn it back down. So I was kind of making a crappy version of Hypothesis, but it was super easy to do that in PyTest. So that was a very fun thing. And the other classic bad decision of PyTest was to teach people PyTest, I wanted to make an interactive coding challenge. Interactive coding challenges, if you haven't seen them, they're very often web-based. If you think of like HackerRank and Friends, but I wanted it to be more like story-based, almost like a PyTest RPG or PyTest roguelike. So, and I was thinking, like usually interactive coding challenges you have to have a web page, you have to have a sandbox, you have to have tools that can test code and assert stuff about code and display output. And I was like, well, PyTest kind of does all of that. You can customize anything about those behaviors. So I had this thing called Instapoker, which is basically you are working for a kind of satirical startup company, and your virtual boss sends you emails, which you can check through a PyTest command. So you do PyTest -- email, and your boss tells you to do something, and then you can do PyTest -- submit, and that turns on a bunch of secret hidden code that evaluates did you actually do the thing, do the acceptance tests actually pass, and you either get rejected or your boss gives you a second thing to do, and it just kind of goes on and snowballs. And
I can't tell you how glad I am that wasn't on a slide.
that would have been a lot of slides, but yeah, that was probably the wackiest thing I've done with PyTest so far, but there is still room for more.
Last week, yes.
Hi, are there any AI tools that will generate the PyTest code?
That's a good question. I am not familiar with code specific, or with tools specifically for this. I think anecdotally we can say that Claude and friends will write PyTest tests. PyTest is popular, so it's pretty easy to get it to do that. I will say, I guess, and again, this is my personal opinion, if you consider tests as a way to kind of define the broader contract of your code, or like what are the most important things I want to be true about my code, I would kind of prefer to be writing those myself. But I could definitely see wanting to get help from an LLM for sure.
And I'm sure people have hit this too. You have to be careful too, because you'll watch Claude say, well, this isn't passing, this isn't passing. Okay, assert true equals true. Great, let's go.
Yeah.
More like they will generate it, and then you obviously have to type all the
Actually, what people do, and it's a proper way to use AI, you tell AI to write unit tests first, like before writing the code, and then you tell AI to write the code that will make the test pass.
Yeah, so you can sort of trick. But yes, you can. But yes, you can trick them into doing test-driven development. And frankly, the people that I know who are most successful at using LLMs to write code are essentially doing that backwards. They are writing tests, and they're making the LLM write the code that makes the test pass. And they aren't allowed to edit the tests, so they can't short circuit it by just changing the test or something. Or you use Git to make, you can undo it if they do disobey your commands, which they will because, yeah, LLMs are a whole thing.
All right. Thank you, David.